All right, thank you very much. So that was a pretty good introduction, so I'll just skip to me. So I've been working for Microsoft for about 8 months now. I spent a long time working on container-related development. I spend most of my time writing stuff in Go. I've recently just become a CNCF ambassador, which is pretty cool. And I've been a Docker captain for donkeys. So yeah, that's me. You can follow me on Twitter and GitHub and bits and pieces like that. So this is what we're going to look at today. The first bit's going to be really interactive because I don't want anyone to get left behind. We're going to make sure everyone understands what a kubelet is before we understand what we're going to virtualize, because if not, the rest of the talk will kind of be hard to understand. And then we'll look at why we needed a virtual kubelet, and we'll look at different implementations. So this isn't going to be a predominantly Microsoft talk. This is going to look at the CNCF project virtual kubelet, but then at the end I'll demo some stuff on AKS because that's what I've got available to me. So what is a kubelet? Who understands here what a kubelet is? Raise your hands. Oh, that's not very many people in the room. So we're going to spend some time talking about what a kubelet is. So a kubelet runs on every node. And what its job is to understand the representation, which is called a pod spec, of what your pod looks like. And the job of the kubelet is to make sure that the pod's either running or not. Now, don't get this confused with the replication controller, because a kubelet will not restart a pod if it fails. It's very binary. It's like, is it running? Yes. Awesome. Is it not running? I'll report that back. And so when you have your YAML and it's type pod and you put all the stuff in it, which like all your container environment and everything, and that gets passed down through the scheduler, that goes to Kubelet, and Kubelet's in charge of making sure that that's running and reporting on it. So this is kind of like where it sits in like Kubernetes world. So you can see there that there's the cry plugin that's talking to containerd. And cry talks to the container runtime via Kubelet, talks to the container runtime via cry interface, and then your container run or your pods run. So that's the architecture of what a kubelet looks like. But the specification there, you can see it's tied to a node. So virtualizing it is going to be like kind of difficult. So does everyone understand what a kubelet is? Like, do you understand the basic concept of it? I haven't gone into all the security around it and a whole heap of other stuff, but at a high level, it's the thing that runs on a node. It runs on every node. It doesn't matter if it's a control plane, doesn't matter if it's a worker node, and it makes sure pods are running. So that's basically what it is. So we can carry on if we understand that. So why did we need to virtualize it? When I spoke about Kubelet, what word kept coming up over and over and over again? Nodes. So when we're talking to customers, if you talk to them about their nirvana of what Kubernetes needs to be, it's like, hey, I want a Kubernetes API, and I want to deploy my application to it. I want it to scale, and I don't want to look after operational overhead of patching nodes, work nodes and all that. So whether you go with AKS, EKS, GKE, the control plane's looked after for you, which is really good, but there's still worker nodes that you have to manually spend operational cycles looking after, patching, upgrading, and all that. So what happens if we could get to the end point where Kubernetes was just an interface? We could go with serverless Kubernetes if we wanted a buzzword. But like you went to a provider, you said, hey, I want a Kubernetes cluster, and you wouldn't even have to think about things like how big does the cluster need to be? How many nodes do I need? VM scaling, do I need a VM scaling set? Another thing that came up when this was first thought about is even on Azure, VM scale sets are slow. So if you need to spin up a new node in your cluster, it's going to be about 3 minutes. Some containers don't live for 3 minutes. And that can go up. So we're looking at different scaling options and also how to save people money, because a lot of Kubernetes clusters are over-provisioned. And if we could find some way to pay for just a pod as you were using it, it would save end users money as well. So as I said, this is the three things that when Virtual Kubelet were made that the product team were thinking about. So removing dependencies for worker nodes. So there is just a Kubernetes control plane, and then behind that is like infinite scale, even though there is a limit to the cloud, we all know that. But you wouldn't have to think about sizing your cluster of VM scale sets or load or anything like that. And I'll talk about an implementation using Virtual Kubelet at the very end with Alibaba Cloud, and they've taken this far beyond the load that anyone else has. Allow burstable workloads. So if you could design your application to be able to be totally elastic on top of Kubernetes and not have to worry about like the underlying infrastructure of worker nodes, that's really, really handy. And there's some projects that are popping up now that allow you to use metrics inside the cluster to look at this and allow you to scale across Virtual Kubelet. And we'll do a demo with one of those. But there's one from Google, so Knative Serving. There's Osiris from Deis Labs, and there's Keda also from the Keda project. And of course, like I said, we save consumers money. So if you didn't have to over-consume like on compute resources and you could pay for your pods per second, like is that a good model? This comes in like really handy when you talk about things like machine learning. So if we could give end users GPU support through the container and not GPU nodes, and they only paid for their like GPU cycles per second, it will actually save them a lot more money than if they were hosting with GPU nodes and not using it all the time. So this is what Virtual Kubelet looks like. So as you can see there, I actually did this talk a little while ago, and I put my favorite indie company up there, HyperSH, and we'll pull one out for them because they're no longer with us. They've gone bankrupt, but they were really cool. So you can see there, Virtual Kubelet is sitting on the node. It sits on it's a Golang binary that sits on the control plane, and basically it interacts with Kubernetes and makes it think that an API is a node. So I've put there like us, AWS, and HyperSH, but they're not there anymore. But so basically that would be interfacing with Fargate. On Azure, it's ACI. And basically it would see the compute resource of the container hosting infrastructure as a node for you. And then you can start to burst your workloads on there and deploy pods. So this all looks really good, right? Your API server talks to Virtual Kubelet exposes a node, and it sits there as an abstraction over an API, and then it looks like another physical node to Kubernetes. This was what was the architecture that came up with that we thought would work, and the first iteration of it was really good, but then we found limitations, and I'll go through some of those as well. So this is what Virtual Kubelet gives you. So if you have a look at Virtual Kubelet, it gives you like all the things that you would expect in a pod, in the like get pod node condition and everything you would expect that like some of the nodes do. But there is some limitations to it, and that's why I'll talk about Virtual Kubelet, the open source project, and then I'll go into Virtual Node, because there's some things that you have to build in to make this work securely across. Where the open source project, we'll go through a demo, we'll just deploy a pod in ACI and it'll get a public IP address. And that's cool, but it doesn't talk back to the cluster. And then we'll use Virtual Node where we'll see the CNI plugin goes across. There's a VNet that has secure communications between ACI and my Kubernetes cluster, and then I can scale accordingly across that more securely. So there's different implementations of Virtual Kubelet. Depending on the cloud provider. But before I talk about the implementations, Virtual Kubelet's been split into two things. So there's Virtual Kubelet Core, so you can find that under Virtual Kubelet /Virtual Kubelet inside GitHub. And there's Virtual Kubelet plugins. They have just been moved out of tree, so they're no longer in the tree of Virtual Kubelet. And each cloud provider or open source contributor can contribute to the cloud of their choice. So like there's a plugin for Fargate, there's a plugin for ACI, there's a plugin for Nomad. There's a new HTTP plugin that there's some experimental stuff being done with Rust. There's a whole heap of plugins, OpenStack as well. So these are the cloud providers using or other people using Virtual Kubelet. So if you can see there, Alibaba Cloud's up the top. That's because they're probably contributing the most to Virtual Kubelet at the moment after Microsoft and CNCF. They actually have come up with a multi-tenant Kubernetes design that uses virtual kubelet. So they have a control plane that then looks after the other control plane, and the child control planes have no nodes. They all use virtual kubelet. They've also built an open source project called Viking, which allows you to route DNS between virtual kubelet and the virtual node on their infrastructure. And that also allows them to run service mesh. So they run Istio across that. So that's quite a good setup. They've taken this really, really far. AWS has got Fargate, of course. We've got ACI. And like in theory, you can talk to any of the clouds on virtual kubelet, but like don't do that because you'll have no networking or anything like that. Don't look at it as a like, hey, I can do blue-green cloud because like it won't work. But if you're interested in like playing around with it, have a look at the dev build, fire up Scaffold. It'll fire up Minikube and it'll like connect you to a cloud. So your laptop is like the control plane, and then you'll start like having virtual nodes on any of the clouds as long as you've got permission. It's kind of a fun thing to do just to play around with. And one of the most important things is virtual kubelet has turned 1. And we got Windows supporting that way before Windows was in 1.14 Kubernetes. So there was a lot of people that were running workloads on Windows. GPU support was important. So one of the things that we found with virtual kubelet that we didn't know before was like a lot of machine learning people like this, because they can like do burstable machine learning workloads on GPU support across ACI, which was working out a lot more cost effective than having like nodes with GPUs in them. There's a university in the US I'm working with at the moment to implement this at a large scale. And of course, I've spoken about all the different cloud providers and everything, so we needed to find a home for virtual kubelet. So it's found a home in the CNCF, which is awesome. So what that means for you, if you want to learn about it, if you want to do anything, all the meetings are open. You can join the group and talk about things. You can contribute. It's on Slack. It's kind of sucky in this time zone to be involved in the meetings because they're usually at 1 a.m. But there's recordings and notes and stuff. So if you really want to be involved in it, you can. And CNCF is a really good place. Like there's Kubernetes, there's a whole heap of other stuff in there. gRPC was brought up today that I really love as well. So yeah, I'd say if you're in this room, you should like definitely check out something in CNCF and like jump on a Slack channel and just start talking to some people. You'll make some really good friends, and it's a really good community. So now I'm going to show you the open source version of virtual kubelet and what it can do. It actually takes a second for me to do it, so I'll just deploy it and then we'll explain what we're doing and we'll come back. So actually before I show you, I'll do kn, which is a lazy sysadmin of Kubernetes get nodes. Because I type it so many times a day, it's just like kn's a lot quicker. But as you can see there, I've got my normal AKS node pool. It's running 14.3. And you can see that I've got the virtual kubelet ACI connector installed, and it comes up and looks like a single node. And you can see there also that I've got the Windows connector. Unfortunately, I don't have any Windows demos. I'm going to use Linux. As you can see here, I work for Microsoft and I'm running Ubuntu, so I'm quite firmly in the Linux team. So I don't have any Windows stuff. But yeah, we'll just deploy this, and then I'll come back and I'll show you, because it's going to get a public IP address and a few other bits and pieces like that. It takes us just a second. So basically what I did there, just to be a bit, so this is installing it on AKS. Like the instructions on AWS will be slightly different. So basically we just use our CLI, and basically what this does is just invokes a Helm chart in the backend and then installs it on your cluster for you. So you just need to make sure that you've got the right permissions, service principal permissions, to be able to execute it across your cluster. You can see it's installed with kube control get nodes, like I showed you, the ACI connector. It doesn't take too long to come up. And basically what I've done is I've just deployed a single pod to that. One of the things that you really, really want to worry about, because we won't worry about the top bit, But this is what we need to worry about is the node selector. So you can see there on the node selector, I'm saying that this workload needs to be on virtual kubelet. I can see that the provider is ACI, so Azure.com. So if that was AWS, it would be aws.com/Fargate. And you can see that's how Kubernetes knows how to schedule the node, the application on virtual node. So that should, and then we can get, we'll have a look now. Hopefully this is done. So was it VKM? Oh. Yeah, once. Okay, cool. So you can see that that's up and running now, and I've got a public IP address. So you can DDoS me. This isn't going to do anything to me if you DDoS it, because it's like 3 lines of Go and a GIF. V-Down, and hopefully this works. And awesome. Okay, cool. So we've got a really, really basic web app just running on virtual kubelet now, and that's really cool. And it's running, and it's got its public IP address, and everyone can access it. But what we found is like services need to talk back to the cluster, and that this implementation of virtual kubelet hasn't got the CNI to be able to talk back. So that was a limitation of the original version of it, and now what has happened is the discussion has been that each cloud provider should be able to provide the interface for them to be able to use virtual kubelet, because the implementation of networking on Azure is different to the implementation of networking on AWS, for example. So the cloud can take up and start running with that. So that's like kind of a cool demo. I'll just change my Okay, I'm just switching my cluster now to a proper virtual node cluster. Okay, cool. So now we'll look at virtual node. This is like the implementation that we've done in Azure. It's not too dissimilar to what Alibaba Cloud have done it either, to get this up and running securely and allow this to be fully burstable. I've also added in a couple of slides that I'm going to show you about a scale to 0 application called Keda that's open source. And we'll grab some metrics off the cluster, and we're actually going to scale out across virtual node running on RabbitMQ. That could be Prometheus or a whole heap of other stuff, but we'll go through that. So the main difference is that, like with the virtual node implementation, when you spin up your AKS cluster, you need the Azure CNI plugin. What that will do is create a VNet that talks to ACI, and the traffic will route over that instead of over the public. So that's definitely something that you want to do from a security point of view. And all the services can speak back and forth. So that's really good. So if you've got services and there's like a service endpoint, you can speak back. Most people want that functionality. And it's still the full functionality that we showed on ACI before, so GPU, Windows, and Linux support. So this is kind of what it would look like with the ACI instance. So it's basically the Kubernetes control plane, and then you see the virtual kubelet, and there's a networking stack that goes into ACI. And you can have like your normal VM stack as well. So what this allows you to do is schedule workloads on either the VM or on virtual kubelet. So one of the interesting use cases that we've seen is Alibaba Cloud use their virtual kubelet for their Black Friday sale. So I don't think anyone else has had that much traffic through any of like stuff that virtual kubelet has used before. And basically they were scaling all the transactions out on virtual kubelet on their ECI platform. And it was taking like some ridiculous amount of transactions a minute, something like 11 million transactions or something. And the reason they use virtual kubelet is like even their VM sets were too slow. So if a new VM spun up and their Kubernetes cluster couldn't get spin up a new pod for transactions, if you're getting 11 million transactions in a minute, you need something fairly quick. So they decided to put the load on virtual kubelet, and they used it successfully. They actually talked about it at KubeCon Barcelona, and I've got the link to the talk after that if you're interested. So this is the real world. So this is what we're seeing in Azure, the real world why people want to use this. So there's burstable workloads, auto-scaling in pods. So this works really well with a horizontal pod autoscaler. As long as you've got an application that sits in there that tells the horizontal pod autoscaler to scale the virtual kubelet, you need some controller there. So whether it be like Knative serving, Osiris, or Keda, because you can't scale natively a service down to 0 in Kubernetes, it doesn't allow you to do it because of the routing. So you need a controller sitting there to tell Kubernetes that there is something below it, even if it scales to 0. And machine learning was a side effect of this that we didn't see coming, but we've seen a lot of people use virtual kubelet for machine learning and GPUs. So I'll talk a little bit about adding Keda to this and what Keda is. So Keda is like event-driven auto-scaling. And basically what it does is it sits in line as a controller with a horizontal pod autoscaler and the service type. And it says it's fine that there is a service there to route to, even if there is a pod not there. So the routing doesn't get all messed up in Kubernetes. And yeah, and it works with native Kubernetes types. So as I said, it does 2 roles. It is really lightweight. Keda only does one thing, and it just listens to metrics and it starts scaling. Whereas in Knative, you have to have Knative serving and a whole heap of other stuff involved as well. So this can work with Knative as well. You can replace Knative serving with Keda, but it's like not the whole shebang that Knative does. So it basically just looks at events, and you need to give it an event provider. So an event provider could be RabbitMQ, could be Prometheus, could be a whole heap of other stuff, Kafka. And then it looks at the metrics from there, and it decides on the scaling mechanism that you should do, depending on what scaling metrics you give it. So as I said there, it's a metric server. Second, it acts as a metric server to horizontal pod autoscaler, so it sits there as an abstraction over one of the metrics grabbers, that's not the right word, but where the metrics go in. And it's able to look at like message queues and a whole heap of things to scale out. So this is basically how Keda sits in. So you can see there is the scale of the controller and the metrics adapter, and it talks to horizontal pod autoscaler. And you need some sort of trigger to make it all scale, and then it just scales the pods. So it sits really lightweight inside Kubernetes and can allow you to scale. This was originally to do with functions and other things, but it can be morphed into anything you need. So the demo I'm doing now, it was actually written by Jeff Holland to do show Azure functions, and then I migrated it to move it to virtual kubelet and didn't change any of the code. I just changed some of the trigger events and where the node definition was that it was going to trigger, and it scales perfectly fine across. So Keda can do functions, or it can do long-living pods, depending on what you want. And as I said, this is the right word, event sources. I said event grabbers, event sources. So you can use any sort of event source. So Kafka, you can see AWS is there. Azure Service Bus, Prometheus would be a very popular one, probably in the Kubernetes ecosystem. And yeah, so this works really, really well. So demo time. So again, I'm going to fire this up because it takes just a second. So you can see here, if someone wants to know about CNAB as well, come and see me, but I'm using CNAB right now to deploy this. There we go. So basically we'll just watch, so control get HPA is just watching the auto scaling events on Kubernetes, and we'll watch the pods to make sure that they're getting scaled on the right node. So you can see now that it's spinning up RabbitMQ, and it's going on my node pool, which is where I want to run it. So let's have a look at the code of what I've just done. Because the CNAB, the one CNAB command there made it look really easy, but there was actually 16 things happening in that cloud native bundle, so I'll debug what I just did. But yeah, that's the power of CNAB, so that's a whole nother talk, but if you want to see CNAB, come and see me as well. So basically what that did is it's installing a Helm repo, so it's installing Keda core via that. It's adding the repo and then installing the devil. chart. So that one command did all that. So basically that's just setting up the horizontal pod autoscaler and the event part of it, so the Keda core. And then I've installed a second Helm chart in the CNAB bundle. So it's just installing RabbitMQ, that's straight from upstream. And you can see there that the password is stable, the super secure password of user and password, just for demo purposes. And you can see there I've just deployed a standard deployment, which is a RabbitMQ deployment. You can see there that it's going to go on virtual kubelet by the nice magenta text there that I've highlighted. So there's nothing there. And also, this is not being cached anywhere. This is coming from Docker Hub, so you'll see the scaling events at real time from pulling to Docker Hub down to an Australian cluster, which is pretty fast. So I haven't cached anything like in local Azure container registry or anything like to make it look better. It's actually coming from Docker Hub. And then you can see that there's CRDs for Keda. So you can see the scaled object. This is where that I'm specifying the metrics that I want to scale at. And you can see there that I've specified the RabbitMQ cluster and what to have a look at. So this is the Keda CRDs that will keep making sure that the scaling is happening correctly. And then this is just the batch. So this is just doing some like fake data, so things will scale. So hopefully, if I go back to my demo, that's the CNAB bundles installed. You can see there that my RabbitMQ consumer is scaling. So you can see there that the replica was 0, then 1, then 8, then 16, then 30. It won't go beyond 30 because I'm like put it at the limit of 30. But already you can see that it's scaling. And if you have a look, it's going to keep saying 30 and 30 because like it's kind of like a serverless function. So if we go over to my other tab, you can see now that it's running, terminated. This is the consumer consuming the queue and then doing a thing and then dying. So it's kind of like actually just in a service loop. But you can see now on the node that there's nothing being spun up on my Kubernetes cluster. It's all being spun up on virtual node or virtual kubelet. So it's talking back to the cluster. Now this is like super cool if you have some application that like a sale or anything like that, you can change the deployment type and start scaling it out and not bomb your cluster with resources being hammered. And you won't get like pod creating and it just sitting there and waiting for things to happen. So yeah, so that was it. The demo really worked, which was really cool. Considering that was a fairly extensive demo. The demo gods have favored me. I'll shout myself a coffee after this. So yeah, so this kind of like is like a simple serverless like demo, but it shows you the functionality. There's some ideas I've got about writing an application to do mutation of a deployment depending on the 116 priority. So in Kubernetes 116, there's like you can set priority on pods. So depending on the priority on the pod, we should be able to mutate the deployment and then spin it out to virtual kubelet. That would be really cool. I've just started to map some ideas around that and think about it. But it could sit there as a controller or possibly an operator or there's a whole heap of things it could be. But yeah, it could like do an inline mutation depending on resource and the event source, and then mutate the deployment to move it off cluster to virtual kubelet, which is like seems like a good idea. I don't know if you think that's a good idea, come and see me because I've like just been thinking about it. And I'm not sure if I'm going to do it yet, but yeah, some people, when I've been talking about virtual kubelet, is like, how do you automate that? And at the moment, you manually have to change the deployment. And I was like, oh yeah, that's not a bad idea. So come and see me if you think that that's a good idea. I'll be more than happy to talk to you about it. Just so I stop smashing my cluster, I'll just uninstall. Again, this is CNAB. It'll just uninstall that whole thing with one command. If you want to know more about CNAB, come and see me as well. So as you saw there, we scaled out an application. So we've seen like virtual kubelet upstream, and we've also seen virtual kubelet properly. If you want to see a really good talk, a good friend and colleague of mine, Jeremy Ricard, and Li Zheng from Alibaba Cloud did the Maintainers Deep Dive at KubeCon Barcelona. And that's a really good talk. And Alibaba Cloud talks about service mesh across virtual kubelet. They talk about some of the stuff that they had to implement in Viking for DNS resolution across that's not in core. And Jeremy goes through the code base, so if you're interested in either contributing or just how it works, the nuts and bolts stuff, definitely check out that talk. If you want any of the code from today, I've got this Kubernetes on Azure workshop. All the code's in there. There's like lessons on all this stuff. It's like, besides spinning up the cluster, it'll work on AWS and GKE. Don't tell anyone that. There's no really Azure specific stuff after the cluster's spun up. So if you want to still learn about this stuff and you're not on Azure, don't tell my boss, but you can use this on anything. Like all that sort of stuff's open source. There's a whole heap of surface mesh stuff that's open sourced. And besides spinning up the cluster. Actually, the virtual kubelet stuff might not work because I don't know the networking stack and you have to spin up the cluster. Well, at least on Azure, you have to spin up the cluster with the networking when you provision. You can't retrofit it, but I'm not sure if that's the case on other clusters. If you want to find out, speak to Jason about AWS, he'll tell you.